So today we're going to talk about the law of cosines. And so again, you're going to use law of cosines to solve triangles that are not right triangles, but where the law of sines doesn't work, pretty much. It's a little bit more difficult, not more difficult, but more work than law of sines. So the law of cosines, first of all, so that you notice in these notes, is they refer to when you have a side angle side situation, so two sides and the included angle, or when you have three sides, okay? And so again, in these instances, the law of sines would not work. So you have to have an alternative for that. Okay, so there's two sorts of forms, right? You've got the standard form and the alternate form. This alternate form at the bottom is basically where you take, for example, the same equation 1 up here, and you solve for the cosine of A by moving everything over to the left. I don't think it's worth for you to memorize everything, and I do believe that we're going to be giving you these formulas, but in case we don't, this is really what you need to memorize, okay? And so remember that capital A's or capital letters refer to angles, and little letters or lowercase letters refer to side lengths. So here, if you have side angle side, what you're going to be looking for is, what two sides do I have? Do I have side A, B, or C, right? You're going to have two sides, and you're going to have an angle. And so the formula works as such. Let's say I'm trying to find side A. Well, side A squared equals side B squared plus C squared minus 2 times B times C times the cosine of angle A. And so again, that's a lot to kind of memorize, but start to kind of notice the pattern. Notice whatever letter is over here, it's the cosine of the angle that matches it. And this stuff in here are the letters that are not included. Since this is A, then in here and here we're talking about B and C. So once you sort of notice the pattern, you see it. So if this is B squared, it's going to be cosine of angle B. And in here, I'm going to use A and C because that's not included there. And again here, if I have side C squared, I'm going to focus on cosine of C here. And what's not included in C? A and B. So A and B are going to be these parts. And so order of operations is also something that is going to be critical to get these answers correct, okay? You're going to have to know how to do your order of operations. Notice you're going to have to square a value, square another value, add them together, and from that sum, you're going to subtract the entire 2 times A times C times the cosine of B, okay? So again, order of operations is going to be critical. And then inside, side, well there, you've been given the A, the B, and the C, okay? And so what happens is, again, you could use the alternative form, or you can just fill in the A, the B, the C, the 2, the B, the C, and then obviously you're going to solve for this. I prefer to just plug it into here and solve for cosine of A. Just manipulate the equation after the fact rather than doing it before. And so again, we'll talk about that. So in this first problem here, you're going to see that we ask you to solve the triangle and we want you to round it to the nearest hundredth. So I'm going to come over here and I'm going to still do what I did when I did law of sines. I'm still going to draw my triangle. I don't know if it's an acute triangle or an obtuse. I'm just going to draw it like that. I know little a is over here, it's 8 feet. Little b is down here, it's 19 feet. And little c is 14 feet. And so when I get to this particular scenario, I need to sort of figure out, I've got 3 sides here, which side am I going to start with? Okay, technically, I know logically you have those formulas. You should be able to start really with any side. You know, I could do the A squared formula and I could focus on the side opposite the A and start there. I could do B squared and I could do C squared. But we do have a pattern, and what we want you to do in this scenario is we want you to start with the longest side, okay? And I'll explain to you the benefits of that later, but it has something to do with the fact that when you start with the longest side, you're going to get the largest angle, and if that angle happens to be obtuse, then the law of cosines is the better way of finding an obtuse angle. And I'll kind of compare that. I'll show you what I'm talking about. But so I'm going to look for the longest side. And in this case, I know that the longest side is the 19-foot side. So I'm going to start with the longest side, and I'm going to focus on that largest angle. So basically, I know that this is little b. So remember, the formula is going to be b squared equals a squared plus c squared minus 2ac times the cosine of angle b. And again, that formula, you're going to memorize it, and you're just going to plug in. So I know this is going to be 19 squared equals a squared, which is 8 squared, plus c squared, which is 14 squared, minus 2 times a times c times the cosine of angle b. So you're just going to do some math here. And you're going to get 19 squared is 361, 8 squared is 64, 14 squared is 196, minus 2 times 8, so 16 times 14. You're going to get 224 times the cosine of angle B. So you're just going to keep doing your math. I know this is kind of a pain, but, got to do it. You have a calculator, so it's not going to be too difficult. 260 minus 224 times the cosine of b. Please remember your order of operations, guys. You cannot subtract these two together because 224 is being multiplied to cosine of b. So what I'm going to do is I'm just going to subtract 260 from both sides. Okay, so I'm going to get 101 here. Okay, 101 equals negative 224 times the cosine of angle b. Divide by negative 224. Again, your algebra is going to be really important here. And basically, you're going to get that the cosine of angle B equals 101 divided by negative 224. So it's going to be negative 0.45089. Now again, I got this. B is an angle. And when I'm looking for the angle, you're going to do the inverse of this amount. And so this is something we're going to talk about. Remember, when we were doing inverses before and we were trying to find angle measures, I had told you, well, hey, when there's a negative, change it to a positive, find the positive cosine, and that way that's your reference angle and blah, blah, blah. But here, I'm okay with finding an obtuse angle. And the cosine, when the cosine is negative, right, cosine is positive here, cosine is negative in this quadrant. If I find an angle, what this is going to give me is this is going to be, when this is a negative number, it's going to be an obtuse angle. So if you notice, if you go to your calculator and you do the inverse cosine of negative 0.45089, it's going to give you positive 116.8. That is the angle measure. So that is angle C. Angle C is an obtuse angle. So when this is negative for cosine, you're going to find that it's an obtuse angle. So now I have my first angle here, and it's 116.8 degrees. So when they want me to solve a triangle, remember, they're asking me to find everything. Well, I already have little a, I have little b is 19, and little c is 14. Let me move this down a little bit. Let me fix that. So let me do angle A, I still haven't found. Angle B, I now know is 116.8, and angle C. So now I have two angles to go, and technically, I could use the law of cosines now for the next one and the next one. Sometimes you get an incorrect answer by doing it that way, but it is a method that you could do. But we don't really push that, and we don't really want you to do that, okay? What we're wanting you to do at this point is to now go and do the law of sines. I want you to find A or C, right, using the law of sines. So what we're going to do, I'm going to erase this out. Let me kind of go over here. Just try to keep it. So now, if I wanted to do the law of sines, notice that I have side B and angle B. So that could be my ratio, right? So law of sines, and I'm going to do that, and I'm going to do 19 over the sine of 116.8 right? Equals, and I'm going to have another ratio. So I could either do C or I could do A. Now you might say, okay, well, which one do you want to do? Which one should you do? Well, what I try to do is, in this case, I try to choose the smallest of the ones that are left, okay? I always choose the smallest. Now, in this case, it doesn't really matter because I already have an obtuse angle, but sometimes I just choose the smallest because I want to make sure I'm not going to get an obtuse angle. So it's just like a habit. So since 8 feet is the smallest side, then I'm going to find angle A, which is the smallest angle. So it's going to be 8 over the sine of angle A. And again, I'm going to do my typical math that I did yesterday for this. 19 sine of A equals 8 times, I don't have to put a parentheses there, sorry, 8 times the sine of 116.8 degrees. And if I divide by 19, I'm going to get the sine of A equals some number. So again, I'm going to do 85 times the sine of 116.8 degrees. Make sure your calculator is in degrees and not radians for this, and I'm going to divide by 19. And I'm going to get the sine of A equals 0.37582. And then again, I'm looking for the angle, so I'm going to have to take the inverse of that value. And so again, now we're thinking, okay, well, what angle is going to have a sine of 0.37? You know from the past, there's 2 angles that are going to have a sine of that. There's going to be one in quadrant 1 and one in quadrant 2. Quadrant 2 represents obtuse angles. Since this triangle already has one obtuse angle, the angle in quadrant 2 is not going to be necessary here. And that's why I like using this method now. I know I'm only going to be focusing on the angle in quadrant 1. So I'm able to just go to my calculator and find the inverse sine of this. I'm going to use it, gives me my reference angle, but my reference angle is my angle in quadrant 1. And I don't have to worry about quadrant 2. So 22.1 degrees. So now I have 22.1 degree for angle A. And then now lastly, I'm going to find angle C. And angle C is easy because all I have to do is do 180 minus angle B minus angle A. So I'm just going to subtract the 2 angles I have, and I'm going to solve it that way. No need to work extra. 116.8 minus 180 minus 116.8 minus 22.1, and I'm going to get 41.1. And so 41.1 degrees is my third and final angle. I've just solved the triangle. So you're going to use the law of cosine one time, basically, okay? And again, this was a side. Each method has a little bit unique, but you're going to use the law of cosine, and you're going to start with the larger side, okay? Then from there, you're going to go to, so second steps, this is 1. Second step is you're going to use law of sines with the smaller side, okay? Smaller side. And then step 3 is you're going to subtract from 180 and find the third one. So again, kind of interesting, kind of different, not terribly hard. Okay, so now I come to my second problem, and I notice I have an angle and 2 sides. And so this one's a little bit different, but I'm going to start it out the same way. I'm going to do angle A, angle B, angle C. Angle A is 25 degrees, little b is 9, and little c is 12 over here. Okay, so I don't have little a. Because I've been given angle A, I know that I'm going to start with that combination. So this is a side, angle, and side problem. Notice it's a side, the included angle, and the other side. So for these, we're going to start with that. Then we're going to start focusing on that A. So I know that the formula, again, is A squared equals, and it's going to be B squared plus C squared minus 2BC cosine of angle A. And so if you notice in this one, you have everything here. You've got B, 9 squared. You've got C, 12 squared. So 2 times B times C. And then the cosine of 25 degrees. So this is a matter of just really punching it into your calculator, just making sure that you have everything in the proper order of operations. Personally, I would put this in brackets in your calculator. If you're going to enter it from left to right, I would do 9 squared plus 12 squared minus parentheses or bracket, and then I would do 2 times 9 times 12 times cosine of 25, whatever. But anyway, if I just do it the long way, let's say I don't have a calculator, it's going to look something like this. This is 216, and the cosine of 25 is 0.90631, something like that. 9 equals, so then I've got, kind of come over to here again, 81 plus 144 is 225. Again, this is a squared, right? Minus, and then here, 216 times the cosine of 25 is going to equal 195.76. So we do 225 minus 195.76. And we're going to get 29.24. So a squared equals that. And now you're taking the square root of a. Since it's a length, I only have to do the positive answer to this question. Okay, so that makes it kind of easy. So the square root of 29.24 is equal to 5.407. So little a is 5.407. So again, when we solve our triangle, right, we need angle A, angle B, and angle C. Angle A was given to us, 25 degrees. Little a, little b, and little c. Again, we were given little b, we were given little c, and we just came up with little a, like that. So now I need to find angle B and angle C. And so now is when I'm going to go from this over to law of sines. So again, I start with law of cosine, okay? And I'm going to start with the letter of the angle given, okay? So with angle given, okay? So I started with the A, okay? Now I'm going to move over to law of sines. And you might say, well, which one do I do? Is there an order? Well, there is, because I know this angle here is 25. B or C could potentially be obtuse, but they're not going to both be obtuse, right? If one is obtuse, it's only going to be one. You can't have two obtuse angles in a triangle. So I'm going to look at the lengths, and I see that side B is the smallest, side C is the largest, it's 12. So truth be told, if there is an obtuse angle here, it's going to be C because it's opposite the longest side. So what I'm going to do is I'm going to do the law of sine for B. Okay, so I'm going to use law of sine with the smallest side or angle that I have. Okay, so I'm going to use the relationship of A, 5.407, over the sine of A, and it's going to equal little b, 9, over the sine of angle B. So I'm going to do my math here. 5.407 times the sine of angle B equals 9 times the sine of 25 degrees. And I'm going to divide by 5.407. And that's going to give me the sine of B. So sine of B is going to equal that. So we're going to do 9 times the sine of 25 divided by 5.407, and I'm going to get 0.70345. Now, again, I know that there's two angles that are going to have a positive sign. One is in quadrant 1 and one is in quadrant 2. But I only have to focus on the one in quadrant 1 because I know it's not going to be obtuse. Okay, quadrant 2 angles are obtuse. So I'm going to do the inverse of this, but I don't have to worry about there being two possible angles for this. I'm kind of ruling out the one in quadrant 2 already. And so I'm going to do inverse sine of 0.70345, and I'm going to get angle B equals 44.7 degrees. So 44.7 degrees. Now, angle C is going to be easy to do because angle C is going to be 180 minus angle A minus angle B. So I'm going to do 180 minus angle A, which is 25, minus angle B, which is 44.7, and I'm going to get 110.3. That's my obtuse angle, okay? And so notice I have everything I need. So basically this is how we do it. Again, you want to know the pattern, okay? When you do law of cosines, you're going to want to do the bigger angle or the angle that you've been given. And when you do law of sines, when you go to that one, you're going to always want to choose the smaller angle to avoid the obtuse. So here we're going to work on just a couple more examples. Now this one here has an error in it. If you notice that side, this says angle A is 6 centimeters, but angles are not centimeters. And so this is really supposed to be little a. Okay, so this is a side scenario. And again, remember, we're going to just draw it out so we have a visual. We have A, B, and C. Little a is 6, little b is 8, and little c is 12. Remember that in this scenario, we always want to go with the larger. So we're going to do the c, okay? So we're going to do c squared equals a squared plus b squared, right? Minus 2ab times the cosine of angle C. So now it's a matter of plugging in, okay? So C, we get 12 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of C. So again, it's a matter of math in your calculator. 36, 64 minus 12 times 8 is 96. Cosine of C. 144 equals 100 minus 96 cosine C. Remember your order of operations here. You can't do anything with this because it's a group. So minus 100, you're going to get 44 equals negative 96 cosine of C. And you're going to divide by minus 96, right? And you're going to get the cosine of angle C equals 44 divided by negative 96. And you're going to get negative 0.45833. So again, now we have this cosine. You see that the cosine is negative. This is telling me that it's in quadrant 2. That's where the cosine is negative. So this is an obtuse angle. So this is giving us angle C is obtuse, which is fine for us. And so we're just going to go to our calculator and we're going to type that. We're going to do cosine of negative 0.45833, and we're going to get that obtuse angle. So inverse cosine of negative 0.45833, and you're going to get 117.23 degrees, or 28 degrees, sorry, 28. Okay, so again, when we're solving this triangle, right, we're trying to get angle A, angle B, and angle C. We just got angle C, right? And we have little a, little b, and little c. So what we need now is angle A and angle B. So now I'm going to go to my law of sines. Here I used law of cosine, and I used it with the larger side, right, being the larger angle as well. Now I'm going to use law of law of sine. Now here, I'm going to use the smaller one just because I'm in that habit. I know because this is already obtuse, honestly, I know that both of my sines, or both of my angles A and B are going to be acute. But because it's like the habit that we do, I'm going to choose the smallest just to kind of stay consistent. So I do it all the time. So I'm going to use my little c over sine of angle C. Okay, equals, and I'm going to do, the A is the smallest side, or smallest angle and smallest side, so I'm going to do 6 over the sine of angle A. So again, I'm going to get 12 sine A equals 6 sine of 117.28, and if I divide by 12, I'm going to get that the sine of A equals 0.4443 or something like that. And then again, I'm going to do the inverse of that value. Now, again, I know that there's two angles that have this particular sign, one in quadrant 1 and one in quadrant 2. However, I know that the one in quadrant 2 represents an obtuse angle, and I cannot have an obtuse angle now because I already found an obtuse angle. I can't have two obtuse angles in the same triangle. So I'm only going to find the one in quadrant 1, which is 26.38 degrees. Okay, so 26.38. And I'll let you know how many to round to. Sometimes we round to the hundredths, sometimes we're rounding to the tenths, so I know that can be confusing. I'll let you know what you need to do. And then I know angle C is just going to be I have angle C, sorry. I know angle B is just going to be 180 minus angle A minus angle C. So when I do the math, 180 minus 26.38 minus 117.28, and it's going to equal 36.34 degrees. So 36.34 degrees. And again, we solved our triangle. Here we come to another problem. Again, it's very, very repetitive. Here we do have an angle. We have angle A. So angle A, angle B, and angle C. This one's 80 degrees. They gave us little b, which is down here. They gave us little c, which is here. And we don't have little a. So we know that when they give us an angle, and we're using law of sines here, this is that whole side angle side scenario, we're going to use the one they gave us. So we're going to do the law of cosines, and we're going to be using a. So a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So this one, again, this is our easiest scenario. So little b squared is 16 squared, c squared is 12 squared, minus 2 times 16 times 12 times the cosine of 80 degrees. And again, remember that this has to be done as a group. So when you're doing order of operations, be super careful. So 16 times 16 is 256. This is 144. If I was to do 16 times 12 times 2, I would get 384, and the cosine of 80 is, I'm just trying to write this out. I wouldn't do it this way. I mean, obviously I would type it all in my calculator in one shot, but I'm just trying to make sure that you have, somewhat similar numbers to me. So when I multiply this, I get 66.681. When I add 256 and 144, I get 400. So I'm still at a squared there, right? So 400 minus 66.681 gives me 333.32. And I have to take the square root, and I know that I want the square root of, I only want the positive root, because since I'm talking about a length of a side, I know my lengths can only be positive. So A equals 18.26 meters. So A is 18.26 meters, okay? And so I just found the first part. So A is 80 degrees, angle B we don't know, angle C we don't know. Little a is now 18.26 meters, little b is 16 meters, and little c is 12 meters. So now I'm thinking about, so I use my law of cosines, right? Now I'm going to use my law of sines. And again, I'm just in the habit of doing the smaller one. I don't really have to worry here, because notice that the longest side is opposite the 80 degrees. So I'm not going to have an angle greater than 80. Both of the other two sides are going to give me acute angles. However, again, use the smallest just to kind of stay consistent. So since the smallest is little c, then you're going to do 18.26 over the sine of 80 equals 12 over the sine of angle C. And again, just for consistency's sake, you don't really have to do it in this case because they're both acute. But again, I think it's important to be consistent and get into your patterns, okay? And then divided by 18.26. So again, you're going to come to your calculator and you're going to do 12 times the sine of 80. And then you're going to divide that by 18.26. you're going to get a number of 0.64719, and then you're going to do the inverse of that, okay? And again, you know your answer's acute, so you only need the one value. So you're going to do the inverse of 0.64719. That's going to give you the angle in quadrant 1, which is all you need. So angle C is equal to 40.33. So again, 40.33. And then you're going to come and do angle B is going to be 180 minus 80 minus 40.33. 180 minus 80 minus 40.33. And you're going to get that angle B equals 59.67 degrees. And there you go. So again, you solved another triangle using that same pattern over and over and over again. Okay, so the last skill we're going to learn is Heron's formula. And this is really trying to find the area of a triangle, okay, when what you have is, let's say it's an ABC triangle, right? You have little a, you have little b, and you have little c. In other words, you have the three sides. It's a side, side, side scenario. And so the formula is the area of the triangle is the square root of s times s minus the length of side A times s minus the length of side B times s minus the length of side C. And so you might say, well, what's S? Well, super easy. S is the sum of all three sides. Really, it's the perimeter, right? It's the perimeter of the triangle divided by 2. So it's side A, side B, side C divided by 2. That gives you S, and you plug S into the formula. So when we work this out, again, I mean, I can draw it out. You don't really need to, obviously, but let's just say you feel more comfortable. Again, you don't need to. A is 43 meters. B is 53 meters, and C is 72 meters. And if I ask you for the area of this triangle, without Heron's formula, you wouldn't be able to do it because you need this height, right? You need a perpendicular height, and we don't have an angle measure to use trig functions, and it's not isosceles. We can't do 30, 60, 90, and so we're kind of stuck. And so we would be stuck without this. But thankfully, because of this formula, we know that the area of the triangle is the square root of S times S minus A times S minus B times S minus C. So in this case, we're like, okay, what's S? Well, again, we know the formula for S is A plus B plus C divided by 2. So A is 43, B is 53, and C is 72, and we divide that by 2. So we get that S equals 84. It's 168 divided by 2, which is 84. So we come back to the formula, and you just type it in, plug it in, 84 times 84 minus A, which is 43, times 84 minus B, which is 53, times 84 minus C, which is 72. Now, obviously, you guys have a calculator, which you can completely plug this into. Okay, we've got 84 times, this is going to be 41. This is going to be 31, and this is going to be 12. So when you get to your calculator and you do all the math there, you're going to get some super large number, whatever that product is, and then you're going to take the square root of that, and the square root is 1131.89. And because it's meters squared for area. And that's it. So you're going to use the formula A plus B plus C divided by 2 to find S. Okay, so you're going to plug S into all those spaces. And the A, B, and C are given to you because for herons, you're always going to have side, side, side. If you don't, you're going to be able to find the third side and you'll be able to apply Heron's.